What's happening there, YouTube? Genji here, and it has been a busy season for new game releases. There have been so many survival crafting games and roguelikes, in particular roguelikes, that have come out recently that my puzzle gaming has fallen way off. So today we're gonna hop into The Farmer Was Replaced, which is a coding puzzling game where we have to program a drone to harvest fields of produce. This one looked really interesting, and I do have a background in programming, so I'm kind of curious to test my wits against this game. But let's go ahead and hop in and see what this is going to be like. Getting started, this window contains information about everything in the game. You can move windows around by dragging and dropping the gray part of the window. Okay, I think we know how to use windows. To get started with programming, go to the first program page by clicking it. Be sure to check out the buttons on the top right corner of the screen, plus I and up. Hover over them to see a tooltip explaining what they do. Create a new code file, open a new info window, and open the unlock tree. Okay, so I guess let's go to the first program page. Text editor. All programming is done in code windows. Each code window corresponds to a text file containing code. You can rename the file by clicking on its name at the top of the window. The code can be edited like in any text editor as long as it's not running. You can execute the program directly by pressing the green play button in the code window. You can create more code files using the plus button in the upper right corner of the screen. You can dock a window. You'll notice that once you start typing, a simple code completion window will pop up. Press tab to insert the code completion. Okay, we have code completion. Good. Use the arrow keys to navigate through the completion options. Okay. Don't worry if this is your first time programming. The language is unlocked step by step, so you won't be overwhelmed by all the things you can do. The syntax is also similar to that of Python. That makes sense for basically an intro to programming you on something that's a little less syntactically involved. So a Pythonic language, one of the most widely used programming languages in the world, so learning it is not completely wasted. If you already know Python, it's not a problem either. You'll just be able to skip the early game quickly and get to the more interesting stuff. Well, we'll see. There are two drone commands available to start, harvest and do a flip. No do a barrel roll. These are function calls. You can think of a function as a command that can be executed. You execute it using the parentheses. Try typing these statements in the code window. I'm guessing this is our code window. And this is, oh, we can drag the whole camera around. Interesting. Okay, so let's do a flip. Function call, play. Hello world, run your first program, and Acrobat, do a flip. And executes, okay, so we can step through it. So we only have these two right now, so I assume we can't just do, like, while and then do a flip. Yep. So let's harvest. Harvest. Here we go. We harvest, I guess this is wheat or hay. Hay. So we can just press this, and every time it'll do one function call of harvest and give us an individual unit of hay. You can think of your code as a sequence of statements, right? So we can do, if we wanted to harvest more than one at a time, because we don't have any kind of looping logic yet, we can just do multiple harvest calls and then have it step through it, and it'll just do it one line at a time. Harvest, 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 harvest. Unlocks. Collecting grass will give you hay. Hay can be used to unlock loops in the unlock menu. Open the unlock menu with a button in the top right corner. Right. So that's this. So, okay, our first unlock is the wild tree. You have unlocked the while loop and the values true and false. The while loop keeps executing the loop body as long as the condition is true. So we'll step back this. So instead of having to type an infinite amount of harvest, so we can just do while true, and then, is this tab? It is tab, not space. Okay, and then we can do harvest, and our little drone here will harvest this one block of hay forever. Infinite loop. Create an infinite loop. Don't worry about creating infinite loops. The delays in the execution will prevent the program from freezing. Yeah, don't do that in real programming. For beginners, perhaps you've already tried to put several harvest calls in. Yep, we did that. The while loop takes the condition, which is a logical value. So true is our logical value. So as long as true is true, which true will always be true, harvest will continue to run in a loop. This is called a Boolean value. The loop then executes the codes inside the loop until the condition is false. We're going to skip some of this because it's just an overly verbose explanation of what we've already demonstrated. While false, do a flip. Yeah, so that will never run because false is never true. Creating an infinite loop is a bad idea because it will freeze the program. Yeah, but in this game there are delays between each iteration of the loop, so it will cause the drone to keep doing a flip until you manually stop it by pressing the execute button again. Yes, and then The line after the colon is indented, so in a C-based language, you would use braces like this to contain a piece of sub-logic. So everything that runs in between these two brackets would belong to this while loop, so this would cause the harvest to run over and over and over again in a C-based language. And if this were C-based, you'd have a semicolon here at the end. But because this is Pythonic, Python relies not on semicolons, but on white space and indentation. So this is the equivalent Python expression of that C expression. So I assume at this point we now have the ability to unlock more things. Let's see, we can get hats for our drone with the change hat function, and then we can pass in an argument hats.greenHat. That costs us 50. Okay, so I see how this is going to work. So we need to harvest a certain amount of materials in order to unlock more programming logic. That's kind of clever. So we'll let this run for a bit. We need this to run to at least 50. I would almost like for a way to speed this up and or reduce the delay between lines, just so that we're not wasting time harvesting in a loop forever. So let's unlock these hats so we can do gray hat, purple hat, green hat, brown hat. So if we add this into our logic here, so we're gonna, every time we harvest, we're also going to change hat to, let's say, can we do variables? Yeah, because right now we have to specify a specific hat. So if we wanted this to be a random hat, we would assign all of these to, say, an array, and then pick a random value from that array. But right now, all we can do is say, we can toggle it back and forth. So we can do gray hat, change hat, gray hat. Oops. And then we can harvest again. Or we can say, we can have it do a flip. Nah, let's just harvest. And then we can change hats again. And then this time we'll change it into the purple hat. Purple hat. So if we run that, he'll change a hat, and then he'll harvest, and then he'll change a hat, and then he'll harvest. So fashionable, equip a new hat. Now this is an unideal code base here, because now we are introducing a significant amount of delay in between each harvest in order to change the hats. But we don't need that much speed. Increase the speed of both the drone and the code execution. This is exactly what I was asking for. So we can make him go faster. We can reduce the amount of delay in between each line of code. Oh, we need 20 wood now. Okay. So grass increases the yield of grass. We need 300 for that. We can expand the farm. You know, if we're going to need this much grass, I'm going to, as silly as changing hats is, we're going to just harvest for now. Because we need a lot of hay. We need 300 to increase the yield of grass. Why are we capped at 72 here? What's happening? The execution speed is doubled. The problem is that the drone now harvests faster than the grass can grow. Oh, see, if I just read, I would have answered my own question. The drone is harvesting faster than the grass can grow, resulting in no harvest at all. To deal with this, if branches and the can harvest function are now unlocked. Checking before harvesting. So far, we have true and false conditions, which of course is not very useful with if. The new function can harvest provides a better condition. Can harvest returns true if the plant under the drone can be harvested, and false otherwise. Okay, so we need something like while true, if can harvest. So we're going to check if the... Can we get code completion here? Can code completion? No. It only works on the initial letter. So if we can harvest. So if the grass is harvestable, can harvest will return true, and then we'll go, it will allow us into this next line here. So then we'll do a harvest. So you run that. There we go. So we should now be harvesting almost as fast as the grass can regrow. There's probably some small time delay between when the execution delay is run and when the grass is actually available. So somehow, I don't know if we'll get into like event-based conditions for the grass, like having the grass fire off an event notice to another function that we have running somewhere. The reason we can use this function as a condition is because it returns a Boolean value. Yep, so it will return true or false. Okay, we understand. So now this is running faster. We can save up for increasing the yield of grass. So I assume we'll get 2. It'll either, I'm not sure if that means that the grass will grow twice as fast, or if each harvest yields 2 grass instead of 1 grass. We can also expand the farm, or unlocks planting, entities.bush. So I assume the bushes will give us wood, because I don't see anywhere else in this tree to get wood immediately here. So let's unlock, we have to expand first. It grew, expand the farm. Your farm has grown. Okay, so you have 3 tiles. This space is not much used if you can't move the drone, so there is a new function, move, that moves the drone. Move requires that you specify the direction in which you want the drone to move. There are 4 new constants for this: north, east, south, and west. For example, move north will move the drone 1 square to the north. If you move over the edge of the farm, the drone will be moved to the other side of the farm. Okay, so we can actually, we'll set this up to, instead of waiting for 1 square to regrow so that we can harvest it again, we'll actually just move north 1 square and then harvest. And by the time we wrap back around to this beginning square again, this grass should be available. So we should theoretically never have a delay in our harvest. So let's try this. Although this does seem like because of the speed of the move, this might be just as fast or slightly slower than our last function here, but I'm sure we're going to have some more things in here, like a bush and carrots and so on and so forth. Okay, so we understand movement. Now, it seems like it's the same, regardless of how far it has to move, it seems like it takes the same amount of time. So moving from this square to this square takes as much time as it takes him to move from this square to this square. He just moves faster when he's rolling back to the beginning. So that's a set time delay, it seems. So we have 300 hay now. We need 50 for bushes, or plant. Grass is nice because it grows automatically. All other plants have to be planted with a plant function. The only plant you can plant right now is a bush. You can pass the type of plant you want to plant to the function like this, plant entities.bush. Okay, so we have an entities class that has a parameter or a member bush. So I assume entities will also contain .grass and .carrot, and so the entities is our codex, if you will, our keyring of different elements, different plants, things that are plantable. This will plant a bush under the drone, call clear to reset the farm to all grass and reset the drone position. It seems that if you grow more than 1 type of plant on the farm at the same time, you can sometimes get a higher yield. You need to research polyculture to learn more. Okay, so let's start this. Let's clear the farm. There we go. So, let's run, just to set up the farm, let's have move north once. So we'll move him north. So he should stay here now. And then we can run plant, I don't know if we have to harvest first or not, but we can try running plant entities.bush. Bushes, plant a bush. There we go. So now we can get grass, bush, grass. Now, I'm assuming that it's not growing. Oh, water level 0. Interesting. So at some point we'll have to, I guess, water these in order to maybe increase their grow rate. But now that that bush is planted, we should be able to go back to our while loop. So while true, if can harvest, harvest. So let's see, oh, nope. Interesting, the bush grows quite slowly. So we can actually probably then do, if we can harvest, harvest. I don't know if we have an else statement yet. We do. If we can't harvest it, we're not going to sit here and wait for that bush to grow because it seems like it grows very slowly. So if we can't harvest it, we're just going to move on. So we'll tell the drone to move north again. So let's run this. Oh, it becomes grass again. So Do we have variables yet? Let's see. Debug operators. Okay, we need to get operators. So we need 10. I see. So for now, we'll have to... Doesn't seem like we need much grass anymore. Everything looks like it costs wood going forward. So I guess we'll increase the yield of our grass just to spend... Yeah, then we got wood, 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 and grass. Wood and grass. So let's do this. So if we can harvest it, then plant entities dot bush. Right? So if we can harvest it, we'll harvest the grass and then we'll move north. And then he's just going to keep moving north until we get somewhere where the bush is harvestable. They'll harvest it and then grass will immediately grow there again. Because grass seems to grow like a plague. But we can use this to just specifically harvest up wood. So we'll let this run in the background. And we're going to need 20 wood to get a speed upgrade. So we'll grab that in just a second here. 19, 20. We'll unlock that. So now we're going to need wood and carrots. So we're zooming now. It doesn't make our bushes grow any faster. But we can catch these bushes slightly quicker once they hit their harvestable phase. Let this guy zoom along. If you grow more than one type of plant in the farm at the same time. Okay, so we'll get to that once we unlock operators. Then I will unlock this second expansion. Your farm has expanded again. Now the tiles are no longer in a nice row, so you need to find a way to traverse a square grid. With the while loop, this is not possible until you unlock senses and operators. Yeah, we're about to get those. It's time to introduce the for loop. You can read all about the for loop on the for loop page, but for now you'll only need it to repeat code a fixed number of times. If we want to do n number of flips, we can do for I in range 5. And what this does, range 5, basically creates a temporary set of numbers, and then the 5 specifies how many individual numbers we want in this range. So in this case, it looks like this is a 0 base, so this will be 0, 1, 2, 3, and 4, which is 5 total numbers, but starting at 0, we only get to 4. And then for I will run through this range of 5 until it hits 5. So in the very first time it loops through this logic, I will be equal to 0. And then once it hits to a flip, it'll come back here to the top again, and then I will increment to 1. And then we'll do a flip, and then it'll roll back around. I will increment to 2, and then I'll do a flip, and then I will increment to 3, and so on and so forth until we hit 5. And since 5 is not in the range of 0, 1, 2, 3, 4, once we hit 5, this for loop will stop and will not progress any further. The function get world size is also available now. It returns a side length of your farm. This way you can write code that won't break with the next expand upgrade. So for I in range, get world size. Okay, so then get world size will return the side length of your farm. Will our farm always be square? I would hope so, because otherwise we're going to need a separate X and Y parameter for this. But this will essentially, because our world is now 3 by 3, get world size will return the number 3, and then we'll have the same situation that we had up here, except instead of range 5, this will be range 3. So this square will be 0, 0, and then this square will be 0, 1, this square will be 0, 2. Oh, it even tells us here, x equals 0, y equals 2, and then once we hit here, x will be 1, and y equals 0, 0, so we have x1, y0, x1, y1, etc. So I think I've yapped so long that we're now up to 246 wood. So we'll go ahead and grab... Oh, we actually can't afford operators. So I'll grab debug for right now. Debug. Sometimes your code just doesn't work and you need to find out why. There are a couple of tools to help you do that. The first is to execute the program step by step. You can go into step-by-step mode with the button next to execute button or by setting a breakpoint. Breakpoints can be added by clicking on the breakpoint panel at the left of the code. When execution reaches the line where the breakpoint is, it will automatically switch to step-by-step mode. Okay? And then we can use the print function to print specific things. Like we can print the value of can harvest, it'll tell us true. We can print the value of get world size, and it'll tell us 3, so on and so forth. So we can use print to get information out of our code that's not immediately available to us in human readable form. Writing into the air can sometimes be a bit slow if you want to print a lot of values. In this case, you can use the quick print function, which prints only to the output window. The print function prints the value directly into the air. So like in the game world. Well, let's try. If can harvest print, we do strings, harvesting, run it. Harvesting. Oh, he does like a cloud trail debug output. Crazy. Okay, well, that is a humongous waste of time, but good to know. So we'll take that out. Okay, so we have to start memorizing some of these things. We have get world size, we have get position to get the current position of the drone. So we know more about the farm that we're working on. So right now we need more hay. So what I'm going to do is take out this plant entities.bush, and we're just going to harvest grass for now. And we are harvesting 2 per. So we're going to wait for this to get to 150, and then we'll unlock operators. And while we're at it, we can unlock carrots. We can read about carrots while we're grinding up our hay. Before you can plant carrots with plant_entities.carrot, you have to till the soil. This will change the ground to grounds.soil. Okay, so now we have a collection of different types of grounds. To till the soil, simply call till. Calling till again will change it back to grounds.grassland. Okay, so this right now is grounds.grassland. Planting carrots costs wood and hay. Oh, interesting. These items will be automatically removed when calling plant entities.carrot. You can see the cost of any plant on its own page. So how do we get to where's the code documentation that tells us all these things? Ah, there we go. General info. Okay, so this is where we can go to reference all of the different programming things that we have available to us. So we can move this to the side. So we can now forward operators. Arithmetic operators. Plus, minus, multiply, divide, modulo. We got a hay farmer, farm 1000 hay achievement. Boolean operators, comparison operators. So all numbers in the game are floating point numbers, so there's no integers. Okay, so all arithmetic operators are floating point operators. Slash is defined to just floor the number after the division. Basically, that means because they're floating point numbers, when you do floating point math on computers, even with what appears to be very specific numbers like 2, actually has a really long trail of fractional numbers attached to it. And floating point math on computers can sometimes have floating point errors, where like doing 2 times 2 may not necessarily equal exactly 4 because there's some tiny insignificant floating point number way off in a fractional space. So they're just saying you can use slash to automatically floor the number to 2, or if you do 2 times 2 and get 4.000000006 or something, you can use this to just get 4. Introduction. Operators allow you to compare, modify, and combine values. The arithmetic operators, blah, 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 are used to perform common mathematical operations on numbers. Comparison operators are used to compare values. The result is always true or false. The logic operators, also called Boolean operators, not and or, are used to combine truth values. So, plus and minus are used for addition and subtraction. Times, divide, and I guess we'll just call this floor, are used for multiplication and division. Floor does the same thing as divide, but the result is floored. Run it down to the next integer. So 5 divided... I guess using floor is not necessarily a good way to describe it because it is a arithmetic operator as well as a floor operation, but I kind of explained what it does already. Percent is modulo, also known as the remainder operator. It divides 2 numbers and then returns the remainder. You can also think of this as repeatedly subtracting the right number from the left number until the remainder is less than the right number. So modulo is a quick way to see if a number is even, for example. If you modulo it by 2, if it is an odd number, it will return a 1, because an odd number divided by 2 will always have a remainder. And if you modulo by 2 a even number, it will always return 0. So you can use that to do like a toggle if you wanted to do every other tile to do a different thing with it. Like if we wanted to do grass, wood, grass, wood, grass, wood. We could use a modulo 2 operator to flip-flop it back and forth every tile, for example. Times is the power operator, so 2 to the power of 2 evaluates to 4, etc. Comparison operators are used, they pretty much describe what these do. They're used to compare two numbers, and the result is always a true or a false. So 2 equals 2 checks if 2 is equal to 2, which it is. Entities.bush not equal entity.bush. It evaluates to false because bush is bush. So bush, if you ask if bush is not bush, then it's false. And then 3 does not equal to 3 plus 1 evaluates to true because 3 does not equal 3 plus 1, which is 4. So 3 does not equal 4, which is true. And then these operators, less than equal to, greater than and equal to, less than and greater than, can only be used on numbers. So they check if the left number is smaller or equal or bigger to the right number. So 1 is less than or equal to 1, so that evaluates to true. 2 is greater than or equal to 3, that evaluates to false because 2 is less than 3. So on and so forth. And then the logic operators are generally used in if statements. So you can use this to combine multiple conditions. So, for example, we have 2 conditional statements here. We have while true, which will always be true because true is true. And then once this is evaluated to true, it rolls into this next statement here, if can harvest. So if we wanted to write this on one line and not have 2 separate lines for 2 separate conditionals, we could actually take can harvest and put this in while true. And we can add an and operator and put this like this. And so what will happen now, this won't run forever now because this is going to, once this evaluates to false, it's going to interrupt this while statement, but it will check now every time if true is true, which it is, and if can harvest is true. So when we run this first tile here is harvestable now. So this will run and it'll harvest. And then as soon as can harvest evaluates to false, it will stop this while loop. So let's run this. It'll run once and then stop because can harvest, once we harvest, can harvest becomes false. And so we get while true and false. So true and false evaluates to false. Right, so the very long-winded explanation for that one. We also have carrots unlocked, right? Yep. We did print and we did operators. So let's see. We've got a metric boatload of hay here and then a little bit of wood. So we can unlock watering. We can unlock trees. Cost of gold, pumpkins, hay, carrots. Variables is probably what the next thing we're going to want to do. So let's get water the plants to make them grow faster. Let's get, well, let's not add watering in just yet. Let's get carrots going. So let's just to set our first like real challenge here. Let's get a row of grass, a row of bushes, and then a row of carrots. So we might need this up here. I might need to reference this, but we can grab our main code here. So this is, we're gonna want to run this forever. So first thing we want to do is get our position. So we have get world size. What was? I swear we had a way to get the position of the drone. Yeah, print the current position, print get position X. Why doesn't that show up? Print get POS X. Error. Senses must be unlocked before this can be... Aha. They're misleading us. Okay, so we're gonna have to just make this, I guess, a kind of a dumb function. So it's not gonna know about its current position. So we're just gonna make it... We're gonna have to make it check every tile manually. So what we're going to do is we want to, the first 3 tiles here, we're going to 4i in range 3. Or we can actually do world size, get world size. So that will equate to 3, and that'll make this code usable even if we expand the world again. So for I in range get world size, we're just going to, if can harvest, we're going to leave this as grass. If can harvest, harvest. And then, regardless of whether or not we can harvest, we're going to move north. Move north. And so this right now will just keep us in a line here. So if I run this, it's going to check if the grass can be harvested, and then it's going to move forward. And then once this for loop has run 3 times, it'll move north back around the beginning here. So we'll stop this. And then once this for loop is done, we're going to tell our little drone here to move east. And now he's going to move over 1 tile here. After he does this, it'll do 1, 2, 3. He's going to loop back around, and then he's going to move over to the right. I believe. Let's see. 1, 2, 3. There we go. So now he's going to keep looping through this. But we don't want him to keep doing grass everywhere. So once he moves over to the east, we're going to do another for loop. So 4i in range. Get world size. Now, we want this one to be bushes, right? So we're going to, if can harvest, we don't need parentheses here, if can harvest, harvest, and then plant an entity dot bush. So that'll turn these 3 squares into bushes. And then, regardless of whether or not that runs or not, we want them to move north. And then we're going to do the same thing at the end of this. We're going to tell him to move east. And then we're going to do this one more time. So I'll copy and paste this for the 3rd row. Copy, paste. And so for this row, we're going to do, if it can be harvested, harvest it. But instead of planting entities.bush, we're actually going to have to till. And then it's grounds dot soil, and then plant entities dot carrot. I believe this is the syntax here. And then regardless of whether or not we did anything, we're going to move north. So this code relies on the state of the world matching our code here. Since we're not doing any kind of reading, we're not reading our drone's position. We're not reading what's currently in that position before we modify it. So if for some reason the world state changes or this gets off sync, like the code starts running while the drone's actually in the center row instead of the leftmost row, this will get out of sync with this, but we have not unlocked the tools to check our world state before we run everything, so this is just going to assume everything is the way that we think it is. Let's run this. There we go. We plant a bush and a bush and a bush, and then we ran afoul of till. Till doesn't take any arguments. How does till work? Tills the ground under the drone into grounds.soil. Okay, so tilling always results in the ground.soil. We don't need this. Now, the problem is going to be that I think if we run this now, again, this is the issue I was talking about. Now, the code is out of sync. So, we're going to have to restart. I'm going to copy this out of here. We're going to run a clear command to reset our boy back to the beginning. We'll paste all this back in, and then we'll run this again from scratch. So, grass, 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 bush, 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 till, plant carrot, till, plant carrot, till, plant carrot. Carrots, plant carrots. Oh, see, something happened here. I never told him to move east again. Aha. See, we ran into our first code bug. So, again, we're going to clear. And what I did not do is, after we got to the end here, I never told him to move east again. So, let's put that in here. Move east. Now he'll wrap back around to our initial starting position. And carrot, carrot, carrot. Beautiful. Grass, grass, grass. Bush, bush, bush. Carrots, carrots, carrots. Interestingly, he did not re-till the ground. Your code triggered a warning. Click the icon to view details in the output window. Cannot plant entities.carrot on grounds.grassland. Well, there's a discrete till call before the call for plant entities.carrot. I'm not actually sure why he's not tilling the ground. So let's, we'll copy all this. We'll clear. And then I guess we'll run through this one at a time. So we can pause execution. So we'll wait for carrots. Carrots. Okay, so now we're gonna run through this one step at a time. So he's gonna move east. We're gonna run 4I and 3. If can harvest. Harvest. So he does harvest. Till, oh. Running till again resets it back to a grassland. Aha. So tills the ground. If it's already soil, it will change the ground. Okay. Read your code documentation. So we need to unlock variables first. Senses. The drone can sense what's under... Oh, senses would also make this easier. So this is a perfect time to introduce senses. So let's unlock senses. The drone can see now. The functions get position X and get position Y return the current X and Y position of the drone. At the start position, they are both 0. Yep, we've gone through this. So 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, and then 2, 0, 2, 1, 2, 2. Get entity type. We can do num items to see how many we have already. Get entity type and get ground type. Return the type of entity or ground that's under the drum. Okay, so we don't need this. So what we can actually do is we can harvest and then we can check if get ground type does not equal grounds dot soil, then we want to till. But no matter what, if we're harvesting, we want to plant. So this will, before we plant, we make sure that it's tilled to soil, and then we plant the carrots. So this should solve our issue. So what we're going to do now is reset the world. Oh, it's clear. Clear the world. And then let's try this. Grass, grass, grass. Bush, bush, bush. Get ground type does not equal grounds.soil. What was the error? I didn't catch it. Oh, get ground type needs to be a function call. There we go. Clear again. There we go. So now the real test will be the second cycle through. Grab the bush, grab the bush, grab the bush. There we go. And then it checks to see if it's soil already before it tries to till it. So it should never attempt to re-till the ground into grassland again. Perfect. So now we've got an unlimited supply of our 3 resources that we have here so far. Beautiful. So what else do we have here? Get the none keyword is unlocked now. None is a value that represents that there is no value. For example, the function that has no return statement will actually return none. Get entity type returns none if there's no entity under the drone. If you want to find out how many particular unlock you have, use the number unlocked unlock function. For example, number unlocked unlocks that speed will return the number of speed upgrades you have. Okay. So this allows us to get information, state information back out of the world that'll tell us about what state the world is in, either globally or specifically about the drone or the area that the drone is over. Okay. So let's go back here. We can get now variables. We can get watering trees. We can unlock more speed. I think that's probably a good idea. There's 3 of 5, so now we need carrots. We need a lot of carrots. So now we should be zooming here, which is somewhat useless. I'm sure it will actually somewhat increase our actual yield, but we're still limited by how fast the carrots and the bushes grow. So we can increase the yield of grass. We can expand again. And because we're using the get world size instead of just a discrete, like 3, a discrete number for the tiles, this should not require us to change our code at all, but it will require us to be in the bottom left-hand corner. So we'll just have to reset this again. So we'll clear this just to make sure that our guy is in the bottom left when we start this. Paste this back in. Now we're going to expand the farm again. Expand. And the next costs 150. We can almost afford another expansion. But now we're 4x4, but we don't actually have to change our code at all because we are using get world size. So this should automatically move from 3 to 4. So if we run this, now we just get bush, 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 and then carrot, 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 carrot. But now we actually need something for this fourth column here. So before we get there, let's, I guess, unlock trees. We need 70 carrots, actually. So what we can do is, once we get to the end here, we can just tell him to move. You know, we can do 2 rows of carrots. So we can just do like this. And now we should have 2 rows of carrots, but we will have to reset again, so clear. Run this. So now we should do grass, 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 push, 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 carrot, 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 carrot. And once we unlock function calls, instead of having to copy and paste, instead of having to copy all this text twice to do 2 rows of carrots, we can just make a function that's like row carrots and then just run row carrot, just to save us some code space. So let's see. We're going to unlock variables. Variables. And while this is running in the background, we'll read about variables. Variables can be thought of as named containers that hold a value. The equals operator is used to declare a variable and store a value in it. Variable name equals value. The left-hand side of the operator is the variable name. You can give it any name you want. The right-hand side is an expression whose resulting value will be stored in the variable. So for example, if we want to declare a variable named a and store a value of 5 in it, we would do a equals 5. And then the right side of this operation does not have to be a specific number. It can be the return value of another function. So for example, here, b would be equal to true or false, depending on whether or not the tile the drone is on can be harvested or not. Don't confuse equals with is equal to. After a variable has been assigned, you can use it in the code to retrieve the value it contains. Yep. Okay. Very good. I don't know if that's going to change our current operation here. We're in a pretty good loop here. It's not fail-proof, so we do have to, if we need to modify this code, we do have to reset the world state to run this, but this should continue as long as the conditions of the world don't change. This should run perfectly forever. So now we're just kind of waiting to grind up some values here. So I guess we're going to need to progress. We can expand to 6x6 if we want. We can increase the yield of carrots. We can unlock watering. Let's see what watering does. Plants grow faster when they are watered. Shocking but true. The ground has a water level ranging from 0 to 1. The function getWater returns the water level of the ground it is over. The growth speed of a plant scales linearly from 1 times speed at a water level 0 to 5 times speed at water level 1. The ground dries up over time. On average, it loses 1% of its current water per second, but there is some random variance to this. Maintaining a high water level will consume much more water than maintaining a low water level. You can use water on your plants. 1 tank of water is automatically added to your inventory every 10 seconds. Upgrading unlocks watering will double the amount of water you get every 10 seconds. A tank holds 0.25 of water. So every 10 seconds, we get 1/4 of a tile of water. So we can only keep 1 tile watered. We can only water 1 tile up to full every 40 seconds. That seems a bit silly. So we have 9 water right now. I guess every 10 seconds this will go up, so this should go to 10 seconds, or 10 units of water. Yep. Very interesting, very interesting. So let's, I'm gonna wait for us to go back to the start. Okay. So if we want to water our carrots, for example, let's say, we'll do this last row watered. So if ground type equals ground soil, till, plant, so when we plant a carrot, we also want to use item water. Oh, items.water. Items.water over any ground to water the ground. So theoretically, every time we pass through here, we should add 1 tank, which is 0.25 of water to the ground. So this should be 25, 25, 25, 25. And then next time we come through, it won't be exactly 50 because this water will have been used up a bit, but we should get closer to 50 on our second pass. But let's see. So we've got water level 0. I don't know if this updates in real time or not, but we'll see. There we go, 0.25, 0.25, 0.25, 0.25. So this is going to slowly drain out, so 0.24, 0.24, 0.24. So now we're just shy of 5. Yeah, 11, 10, 9, 8. Yeah, that watering rate seems really, really slow. So we're going to run out of water at this rate. We're spending more water than we're generating. So we'll need to upgrade that again. Fertilizer grows plants instantly. Receive more water. So 0.1... Okay, so instead of 10 seconds, it'll be 5 seconds. So we need 200 wood for that. We can unlock trees. I think we'll unlock sunflowers and power. Pumpkins. Mazes, cactus, polyculture, dinosaurs, and a top hat. Okay. Let's step into trees, I guess. Trees are a better way to get wood than bushes. They give 5 wood each. Like bushes, they can be planted on grass or soil. Trees like to have some space, and planting them right next to each other will slow down their growth. The growing time is doubled for each tree that is on a tile directly to the north, east, west, or south. Okay. So if you plant trees on every tile, they will take 2 times 2 times 2 times 2 equals 16 times longer to grow. Why is this like a spoiler? Oh, it's telling... Okay. It's giving us a solution for that. So we can actually alternate this last row here. Let's take the items that water out for now until we have a more efficient way to generate water. So we can actually alternate this row between carrots and trees to start generating some trees here. So what we'll do is in this last row here, if it can be harvested, we'll harvest. We'll check, we'll then check if I modulo 2 is equal to 0. And what that means is every even number row will give one result, so it'll be true, and every other one will give false. So we can do, it'll allow us to toggle back and forth as we go up here. So if it's equal to 0, we want to till the ground to soil and plant a carrot. If it's not, then we want to till the ground to grassland. And then plant entities dot tree. So we need to reset our man here. So we'll run clear. Reset. And then we'll run this. So when we get to this row, we should alternate between trees and carrots. Here we go. Trees. Plant a tree. Perfect. Perfect. And because the trees are not planted adjacent to each other, they should have their full growth rate. So as soon as we get back to the start here, we'll stop. Because now I want to unlock something else. I want to expand the farm, which costs 100 wood and 50 carrots. So now we're, what, 6 by 6? There we go. We don't have any pumpkins, so we're going to want to expand into pumpkins. 1,000 pumpkins to expand again. Pumpkins. 500 wood and 200 carrots. So we don't have that much. We don't have that much wood anyways. So we can actually, if we wanted to do, let me go back to trees here. We just have some space, but right next to it will slow down the growth. Each tree that is on a tile directly to the northeast, west, or south. So we can do diagonals. So we can copy this. into this. But we're going to want to stagger the trees. So what we'll do is instead of all the even tiles to carrots, we'll do all the odd tiles to carrots. So let's run this, and we should have trees in diagonals from each other. There's our grass row. There's our bush row. Oh, right, we're 6 by 6 now. So that's actually gonna... we need to add 2 more rows of something. I guess we could just do this again. So that'll basically do this pattern again here. But we will need to clear all this again. Reset our man. Now run it. There we go. So now we should be supercharging wood and carrots here. Because they're the resource that we have the least amount of. New hat unlocked. Farm 1000 wood. Change hats.tree hat. Can we punch our microphone? Can we afford another speed upgrade, I wonder? 500 carrots, almost. Really, nothing was harvestable in that whole line? That doesn't seem right. Oh, I never told it to harvest. I didn't copy that line. So keep running. Oh no, he's starting from the beginning again. Crap. Yeah, I forgot if he can harvest. I forgot that bit. So let's copy this out of here. Let's clear. Let's restart. So if can harvest, if can harvest, if can harvest, and then if can harvest. Okay. Oopsie. Somebody probably spotted that already. I was like, you idiot! You're not harvesting! We just need to get up to 500 carrots. Get our speed upgrade. Yeah, let's see this again. Bushes. Nom 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 nom. There we go. Harvesting. Harvesting. Perfect, perfect, perfect. Not quite 500 carrots yet. There we go. Now we can afford our speed upgrade. Look at him go. It's a very busy drone. Okay, so our next speed upgrade is going to cost 1,000 carrots. So it seems like we could, at certain points, you're going to have to plant specialized crops. So like if you wanted to grind out 1,000 carrots, you just have to run a code that does all carrots for a bit. Can we save? Can we save this script? Open a new window, create a new code file. And we call this one like grass, bush, carrot, tree with camel case. So let's unlock pumpkins next. So we need 200 carrots. We're almost there. Every so often we're getting a bonus harvest on our carrots, I notice. I guess from having multiple types of fields or something. 204, there we go. We're over. Let's grab pumpkins. Pumpkins grow like carrots on tilled soil. Planting them costs carrots. When all the pumpkins in a square are fully grown, they will grow together to form a giant pumpkin. Unfortunately, pumpkins have a 20% chance of dying once they are fully grown, so you'll need to replant the dead ones if you want them to merge. Okay. When a pumpkin dies, it leaves behind a dead pumpkin that won't drop anything when harvested. Planting a new plant in its place will automatically remove the dead pumpkin, so there's no need to harvest it. New hat unlocked. carrot farmer, farm 1,000 carrots. Can harvest always returns false on dead pumpkins. How do we find out if a pumpkin is dead or not? Because, like, if we're just running can harvest, there's no functional difference between, or there's no way to tell the difference between a pumpkin that is alive but not yet ready to harvest and a pumpkin that is dead. Because in both cases, can harvest returns 0. So how do we differentiate between a growing pumpkin and a dead pumpkin? It is a good idea to get at least 6x6 size pumpkins to get the full multiplier. This means that even if you plant a pumpkin on every tile in a square, one of the pumpkins may die and prevent the mega pumpkin from growing. Lists, simulation, functions. Let's unlock functions. So I kind of described this earlier, but a function allows us to kind of group this logic instead of having to copy and paste this multiple times to get these rows to all do the same thing. We can just define a function that's like called carrot row or something like that. And then instead of having to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines of code 4 times, we can define these 13 lines of code once, give it a name, and then just use the function called carrot row or whatever we decide to name it once, and it will automatically run all of the code inside of that function. So use the define keyword to define a new function. Define f defines a function named f, and it defines arguments for this function of arg1, arg2. And then right here, arg2 equals false is defining a default state for this argument. So this is just the format definition. This isn't actually meaningful to us. This is just saying this is how you define a function. You can use the call operator to call the function f42. And so basically if we were to define a function with this exact code and call it with function f42, the 42 is our first argument. This will be submitted for argument 1. And then because there is no second argument, argument 2 was given a default state of false. So this, having f42 like this is the equivalent of having f42 comma false. Because if you do not give it a specific explicit value for argument 2, we gave it an explicit value, so it's basically saying if you don't see an explicit value for argument 2, assume that argument 2 is false. Pretty easy. You've already seen built-in functions like harvest. You can also define your own functions. Yep, we just kind of went over that in probably more words than you have used here. And then return value. Choose the return keyword to make a function return a value. So if we wanted to return a value back out of the function, we would use the return keyword and then whatever value we wanted to return, kind of like defining a variable. And then default function or default arguments we already covered. So if you give the argument a value in the definition for the function, that is the default argument. And so when you're calling the function like f here, if you don't give it a value, an explicit value for a will be assumed to be equal to false. F function call. Here, f calls the function of f, which defines and returns a new function d. The second function call then executes the return function and performs a flip. Doing these sort of things is usually not a good idea because it's hard to see what's going on. Functions that take other functions as arguments lets you get really creative. Okay, so this has been grinding away for a while. Let's see what we have to unlock. We can do lists. We can do import statements. We can import stuff from other files. We can use random numbers. Allows access to the cost of things. Automatically unlock things. What? That's things like cheating. We don't have 1,000 carrots yet for a speed upgrade. We cannot expand again until we get pumpkins online, and we do have pumpkins now. So let's get pumpkins online. So let's stop. We'll wait for him to wrap back around, and then we'll stop. So instead of having 4 rows of carrots, we can, let's define some functions here. So we'll call this define caret row. We're going to use camel case. Sorry for people who use underscores. And then we want to be able to offset this. So we're going to say we can make this, we can use the argument to define what we want the modulo value to be able to say if we want this to be an even or an odd row for trees. So we'll call this odd or even. Whoops, no. Don't correct me. Odd or even. And then the bulk of this body is going to be what we defined here. So we'll copy this out. We'll paste this here. And so whenever we call this define caret row function, it's going to do all the stuff we did to make the drone plant this row of alternating trees and carrots. But because we want to be able to easily specify whether or not we want this to be an odd row or an even row for doing these diagonals of trees, instead of having a discrete explicit value for the modulo result here, instead of a 0 or a 1, we're just going to call this odd or even. And that will allow us to just call this function here. So we've got, this is our grass row. This is our bush row. So starting here, we want to call caret row, and then we're going to start with 1, I guess, because this one's 0, so it's 1 0 1 0. So caret row 1, and then we'll move east, and then we'll do the same thing here. Instead of all this code, we're going to do caret row, but instead of 1, we're going to do 0, and then we'll do the same thing, caret row 1, and then caret row 0. See how much cleaner and more compact that makes our code? So let's see if it actually works. Go run this. And there we go. Oops, I typoed somewhere. F caret row. Nope. So now we're going to have to reset our world state. So we'll copy all this. We'll do clear. Actually, you know what? We could probably, instead of clearing this every time, let's do create a new code file. And let's just run clear in this code file, and then we can just run clear. And then we can just come back here to grass, bush, carrot, tree. And there we go. So that's throwing functions in here, but that's not actually what we want to do with our farm, because we want to start working pumpkins in here. So what we're going to do is, once we get to the end of this again, we're going to stop our man. And then we're going to throw some pumpkins in here for the last 2 rows. So for the last 2 rows, we're going to want to make a new function here, and we'll call it define pumpkin row. And I don't know if we're going to need any arguments yet, because I don't know what this function is going to look like yet. Basically, I'm thinking we want to do a 2x2 grid of pumpkins, because I don't think, like, the pumpkins will only grow in squares of equal length on all sides, right? So it'll be a 1x1 or a 2x2 or a 3x3. So if we're just dedicating 2 columns to pumpkins, we can't, for example, do a pumpkin that's 2 columns wide and 6 columns high or tall. So it'll have to be a 2x2 pumpkin, a 2x2 pumpkin, and a 2x2 pumpkin. So functionally, we don't have to do anything special for that, since the pumpkins will automatically group together, I believe was the way it was described. If we do a new info window and we look at pumpkins, see pumpkins, when all pumpkins in a square are fully grown, they will grow together to form a giant pumpkin. So we don't have to do anything to make them form 2x2 squares. We just have to plant pumpkins next to each other. So define pumpkin row is just going to be for I in range to get world size. I don't know. We have to till the soil, but I don't know if we necessarily want to harvest immediately. And I'm not sure if there's a way to tell if a pumpkin is of a specific size or not. Pumpkins. So we get the yields here. But there's no special feedback or ways that we can probe the state of a pumpkin other than that a pumpkin is the part of the pumpkin that is underneath the drone is harvestable or not seems to be the only thing that we can get back out of there. I believe, let's see. Built-in functions can harvest, change hat, clear to a flip, get entity types. We can check if it's a pumpkin or not. Senses, we can get position, we can get entity type, we can get the ground type. Number of things we have unlocked yet, so I guess we'll just have to copy this if we can harvest, and then we're gonna check if the ground is soil or not. We don't need the modulo part of this now. So we'll check if it can be harvested, we're going to harvest, and then we'll check if the ground is... Yeah, because it'll be something besides a pumpkin first, right? So we do need to check the ground type, if it's soil or not, till it, and then plant entities dot pumpkin. And so now we can do a pumpkin row here for instead of a third and a fourth carrot row, we'll just do pumpkin row, pumpkin row. So let's see how this plays out. And then we do need to do a move north, regardless of whether or not we can harvest or not. And then we need a space between here, and this actually needs to go up. There we go. So we have two functions defined here. Here's our carrot row, here's our pumpkin row, and then we have the while true loop that runs forever down here at the end. So we're going to run this. What happened? Oh, we have yeah, spacing was wrong. So we should have 2 rows of carrots and trees, and then we should have pumpkin, 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 plant a pumpkin. Oh. Now the problem is, if can harvest on a dead pumpkin will always return no, so those tiles are actually screwed. So I guess we're going to want to not... we'll wait for this to run through again, because eventually all of these tiles will become dead pumpkins. So we're actually going to not check if it can be harvested or not. We're just gonna harvest. Because it seems like the pumpkins grow faster than it takes us to loop back around to it, so... we basically want to just reset the state of these pumpkins every time, regardless of whether or not they're ready to be harvested or not, because they're at the end of the harvest routine. They'll always be grown by the time we get back to them. Well, they'll always be grown or dead by the time we get back to them. So let's see how this plays out. There we go. So if the pumpkin dies, we don't care. We just harvest over it. And then every so often we get a 2x2 pumpkin. So I guess we're gonna have to find a way to suss out whether or not a pumpkin is dead or not. I guess the trick would be we would have to treat each 2x2 section. We could basically, we wouldn't be able to just do row by row where we're taking the entire column, sorry, column by column, where we're doing something with each specific tile in the column as we pass through it. We'd have to treat each 2x2 section as its own subsection, and we'd have to have the drone do a circle and check each of the 4 tiles in those 2 columns and see if all of them are harvestable or not. And in the condition that the tile returns not harvestable, we'll know that because the pumpkins grow so insanely fast, if a tile is not harvestable, we can reasonably assume that it means it's because the pumpkin is dead and not because the pumpkin has not grown yet. let's do this. Move east. Oh. Why is it running this script? Whatever. Clear. Doesn't matter. Go. Okay, so if we want to do that, we'll basically have to get rid of these last two here. So what'll happen is we'll go through, we'll do grass, and then bushes, and then our 2 rows of alternating carrots and trees. And then once we get to here, we'll move north to wrap back around to here. We'll move east. And now we're no longer going to want to move up in the column like we did in these first 4. We're going to want to go in a 2x2 grid, check if each one of these tiles is harvestable, and then if not, we're going to want to replant that section. And then, I don't know if we want to wait for the pumpkin to grow, or just move on. So we'll do check, 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 check. And in the condition that all 4 of the tiles are harvestable, that means that the super pumpkin is ready to be harvested. So let's change our pumpkin row to just handle pumpkins, right? So we'll be starting in this position here. And so what we're going to want to do is for I in range, let's call it for X in range 2, right? Because we're going to do a 2x2 grid. And then for Y in range 2. So that's the X, that's X 0 and 1, Y 0 and 1. X and Y. And then we're going to want to get rid of all this. So for very starters here, on our first run through, we're going to want to check is the ground soil or not. So we'll do this. We'll copy this into here. So very first thing we do in each one of these squares is check is the ground soil, and if it's not soil, till it to soil. And then if it's already soil, we're going to want to check if well, we have to do this as well. So if the ground is not soil yet, we're going to want to plant entities.pumpkin. We're going to want to plant a pumpkin there after we till it to get the pumpkin growing. Well, actually no, because of a step we're going to do after this, we can push this down a bit. So we'll take this out for now. So we till the soil, and then we want to check if this can be harvested. So if can harvest. And then we're going to want to store the value of this. Well, no. So we're going to want to check if not can harvest, actually. So we're going to want to check if we cannot harvest this tile. We're going to want to just plant a pumpkin here. Because that means that this tile is either there's nothing planted here, there's no pumpkin planted here, which would be the case after we till the soil. Or the pumpkin is dead, because it's going to take us so long to get through these first 4 rows. And by the time we get back to these pumpkin rows, any pumpkins that were planted and are still alive will definitely be fully grown. We're going to plant a pumpkin. We need a colon here. And if it returns, we're going to want an else statement, because we are going to want to know if this part of the pumpkin can be harvested. So because we don't have lists yet, we're going to actually need to define separate variables for each one of these tiles. And let me get the variables. We just give it a name, okay. So we'll call this x0, y0 equals false. x0, y1 equals false. We're going to define 4 variables here, separate variables, and then later on when we get lists, we'll clean this up a bit. X1, Y1 equals false, and then X1, Y0, sorry. Then X1, Y1 equals false. So this will be the state of each one of these 4 pumpkin tiles here. Oh, the tiles of our super pumpkin. So for X and for Y, can we dynamically address variables? I guess not. So we actually will need lists for this to work. So let me unlock. I would hope we can afford lists by now. Lists. Use to store lots of values. 500 carats. Yep. Lists are an easy way to store multiple values in a single variable. You can create new lists like this. List equals and then an array of things. So the number 2, the value true, or a reference to items.hey. A list can also be empty. So what we're going to want to do is create a list that contains the states of these variables here. So instead of having x0, y0, x0, y1, etc., we're just going to create tile. We're going to create a variable called tile state. And it's going to be an array. And this list will have those 4 values in it. So it'll have the value of x0, y0, it'll have the value of x0, y1, then the value of x1, y0, and then the value of x1, y1. But for right now, it's going to be empty. So the way that we will access this list is using these x and y values. So in each one of those iterations, we're going to want to add a true or a false to tile state to represent whether or not every one of these tiles in this 2x2 square is ready to be harvested. And only in the condition that all 4 of these tiles are ready to be harvested do we know that there is a 2x2 pumpkin here ready to be harvested. So we're going to do that with list.append. So once we get inside here, X and Y, we're going to check if the ground is tilled to soil or not. If it's not, we're going to till it. So if it cannot be harvested, we're going to say tile state dot append false. And if it can be harvested, we know that there is a living pumpkin here ready to be harvested, or part of a living pumpkin here that's ready to be harvested. So we will say tile state append true. So because this is an if-else statement, only one of these will happen. Either this tile or whatever tile we happen to be on will either be in the state of false or true. And then that value will be appended to tile state. And then we'll go to the next iteration of this loop. So y will go from 0 to 1. We'll do all this again. We'll check if it's ready or not. Then we'll add another true or false value to this. So by the end of these 2 loops running to their completion, we will have tile state with 4 Boolean values in there. And so after all this is done, we're going to want to check. Well, first we have to tell the drone to move around. So we'll put that in between there and what we're about to add here. So after all 4 of these, after both of these 4 loops have run, we're then going to want to check each individual value in tile state. So we'll do if, there's probably a few different ways we can do this, but because there's only 4, because we discretely know that there's only 4 values in here, probably the quickest and easiest way will just be to do if tile state 0. I believe we access the individual values of it this way. Let's see. Oh, here we go. Okay, they do. Okay. Yep, just making sure that it is Pythonic in that way. So we can do if tile state 0 and tile state 1 and tile state 2 and tile state 3. So if all 4 of those Boolean values that we stored in tile state are true, then we know that there is a 2x2 pumpkin that's ready to be harvested, so then we'll just do harvest. So we will probably also have to tell it to replant the pumpkin seeds in there, but for now we're just going to tell it to, we'll have to handle the movement function so that the drone can actually get to all 4 of those. So for 0, 0, so we'll assume we're going to start in this square here. So after this inner loop runs once, we're going to want to tell it to move north once. If we're starting here, we're going to go move north. So after this runs once, y will increment from 0 to 1. We'll have moved north once. And then once we get to here, we actually don't want it to move north a second time. So we can use a modulo operator here. Or we actually, if we decide to go with a larger pumpkin, a modulo is probably not the way to do this. We can probably just use a, because we're doing 2 here, we can say if y is less than 2 minus 1, perhaps. If we do larger pumpkins, we'll probably want to swap out a discrete mention of 2. We'll probably want to have like a size variable here, and then we can have size here, and here, and here, and then here. So when we call handle pumpkins, we'll just we'll pass in the argument of 2. So we want to see if y is less than 2 minus 1. So when y is 0, 0 is less than 2 minus 1, which is 1. When y is 1, so we know we're at the end of our 2 by 2 grid here. So in that case, y will be equal to 1. So 1 is not less than 2 minus 1, which is 1. So 1 is not less than 1. So it will not move. So we actually want to go if y is... Can we do not? If not, y less than... Is that valid in this? Because we want the drone to move north only if we've not reached the end of our grid here. So once we get to here, and we can actually test this. What not equals is not a... Oh, if not can harvest, does that work? Is that valid? So if we can't harvest, right? It inverts the value of can harvest. If not, y is less than size minus 1, move north. So when we're not at the end of our grid here, we want to move north. And then now we'll get into the outer loop. So we can do if not x less than size minus 1, then we want to move east. Actually, you know what? Because... No, because we want to reset this every time. So we want to start here, go up, and then once this ends, we want to actually go east and down. Move east and then move down, right? So it'll go, not down, but south. So we'll go north, and then this will trigger. So then we'll go east and south, and then it'll go north again. And then once the end of this loop isn't reached, we want it to go north and east. North and west. Move north, move west. Then we just have to handle our edge case here, which is when we finish. So we'll do this. We'll be here. So we'll go here, here, down, here, here. Then we'll move north and west, and we'll repeat that again. So we'll go here, then north, west, and then we'll do up, over, down, up. Then we'll go north. So we actually probably want to take this west out of here. And what we'll end up doing is we'll do handle pumpkins. With a size of 2. And then we'll call move west. So basically we'll end with this north. So by the end of this, we'll be sitting here. And then for the next one, we'll call in between the 2 handle pumpkin calls, we'll call move west. That'll reset us here, so we'll do all this. We'll go back up here. We'll be sitting here. Then we'll call another manual move west. We'll do all this. We'll move north again, which will bring us back here. And at the end of this, we actually want to do move east to get back over to here. So we'll do handle pumpkins west, handle pumpkins west, and then handle pumpkins east, I believe. This is all theoretical in my head right now, so there's a good chance that this is going to be massively messed up, but we'll have to run it once and find out what happens here. We're gonna run it up to this point. Can I put a breakpoint? Give me a breakpoint here. Because I want to, once we get to that breakpoint, I want to start stepping through this one line at a time. Okay. So now we're going to be moving inside Handle Pumpkins. So if I run one step here, it should bring us in here. So tile state is empty. We're creating a new empty list here. We're going to step into our first outer loop. We're going to step into our inner loop. We're going to check if the ground is soil or not. It's not soil, so we're going to till it. We're going to check if it cannot be harvested. It cannot be harvested, so we just planted a pumpkin. And we set tile state's first list element to false. So it's going to skip over this else statement, because we were the first one equated to true. So then it's going to check if what tile we're in, and if we're not at the edge of our 2x2 section here, it should move north. If not, okay, so that did not trigger properly. So, if not... Oh. No, it was this here, so... If not y less than size equals 1. So y should be 0 here. And size minus 1 should be 2 minus 1, which is 1. So 0... Oh, yeah, so it should actually be this. If y is less than that. Okay, my mistake. So, I guess we'll just have to step back into this again. So let me run clear. We know that up until this point is good, so we'll put a breakpoint here, I guess. I'll run this. Okay, so now, if y, in this case is 0, is less than size minus 1, which is 2. Size is 2, size minus 1 is 1, so 0 is less than 1, so we should move north 1. There we go. And now we go back into the loop. Planted a pumpkin. We tilled and planted a pumpkin, so now 1 is not less than 1, so we should just skip this. We should not move north again. There we go. So now we're going to check if... I think this also has to be equal to true. And I think that once we changed something, it actually interrupted the script. So we'll set the breakpoint here. We'll run clear again, and then we'll run this up to that point. Okay. So now x is equal to 0, size minus 1 is equal to 1, because it's 2 minus 1. So now we should move east and south. Move east, move south, and then we're going to step back into our for loop again. There we go. Plant the pumpkin. Set the third element of tile state to false, so once we get there... Run that, so now tile state, it should be false, false, false. There we go. Do it again. Now we've got... we have to run that. Tile state is false, 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 false. So none of the tiles are ready to be harvested yet because they're all still growing. They were all just planted. So now we're going to break out of this because 1 is not less than 1. And now 1 is not less than 1. So we should move north, and now it's going to recycle. We're going to be moving out of Handle Pumpkins, so it's going to go back to move west. Nope, tile state has never been defined. What are you talking about? It's right here. Oh, capitalization. Capitalization. Dummy. It's always the stupid things that get you in programming. Okay, so I think this should work, so I'm not going to set a breakpoint this time. Well, I guess we can set the breakpoint here. We don't need to see the individual loops now. Okay, so because... Oh, actually, this needs to go before. See, if these pumpkins were actually ready to harvest, we've already moved away from it, so this move north actually needs to go after. That's there. So let's clear this. No breakpoint this time. There we go. So, ironically, all of the pumpkins did not die this time. They all lived, so now we're just gonna grab them. And we solve the issue that once we harvest, we don't actually replant. So once we get around this time, we'll replant these pumpkins. So we have some inefficiencies here, but I want to see what happens in the condition that these pumpkins die. It is working, it's just not because the different pumpkins from different 2x2 grids can join together with each other. It's introducing some weirdness here. So what we'll probably want to do, I'll wait for our drone to get back to the starting position. When we run a harvest, we'll want to also, let's see, so we'll be in this position when we check. So we'll want to run a harvest, and then we'll want to do a plant sequence before we move on. So I'll want to do, like, move down plant, move left plant, move up plant, move right plant. Something along those lines. So harvest, move south, plant, entities, dot, pumpkin. So move south, so we're here, plant, then move west, plant, move north, plant, move east, plant, and then move north into the next section. So let's clear. Run this again. There we go. We have two failed pumpkins. Oh, and the big one, yeah. That's going to be interesting. We do replant at least, but now our super pumpkins are kind of off kilter, but it doesn't actually mess up our ability to harvest them. Okay, and it does perfectly replant it. Good. So this is at least more efficient than our last design. And we'll just have to live with the pumpkins being able to grow off kilter like that. Awesome. Okay, so what can we unlock with pumpkins now? We can unlock cactus with 5,000 pumpkins. Oh my god. Polyculture. Use companion planting to increase the yield. Mazes, top hat, mega farm. Dinosaurs. Who knows? Dictionaries. I don't know how useful dictionaries are going to be in this. Let's see, we can do fertilizer, grows plants instantly. So this fertilizer would be very useful for pumpkins. Because we can, instead of having to check each square, we could drop fertilizer on it, make it grow instantly, and then we can instantly do a check to see if the pumpkin died or not. Because right now we're just kind of we're rolling the dice and dealing with the edge case where it dies and replanting it. But if we can make it grow instantly with 500, at some point waiting for the plants to grow is just not efficient enough anymore. Similar to water, you will automatically receive one fertilizer every 10 seconds, doubling with each upgrade. See, that's going to be the main issue, is that we're probably not going to have enough fertilizer to deal with, to be able to keep up with how many pumpkins we're growing here. Fertilizer can make plants grow instantly, reduces the remaining growing time of plants under the drone by 2 seconds. That's not instantly. It just reduces the remaining growing time by 2 seconds. Plants grown with fertilizer will be infected. When a plant is infected, half of its yield turns into items.weird substance when it is harvested. Weird substance can also be used on plants, which has the effect of toggling the infected status of the plant and all adjacent plants. I see. So you're increasing the logical workload of your drone because you now have to check if the item, if the plant is infected or not, I suppose. Although I don't see... Again, I don't see any state that we can query to see if an item or if a plant is infected or not. Because you don't want to just use weird substance on every plant because it's a toggle. It'll infect plants that aren't infected. Well, I guess you actually do know if it's going to be infected or not because it says there's not a chance. Plants grown with fertilizer will be infected. So basically what you would almost have to intentionally grow some sacrificial crops in order to grind out weird substance. And then clear your field once you have a specific amount of weird substance. And then you want to use 1 part fertilizer. Whenever you use a fertilizer, you want to use a weird substance. Or you just have certain tiles on your farm that have the sacrificial plant on it. So like, if we want just like the top right-hand tile or the top right-hand 4 tiles, whatever ratio of weird substance you need for your farm. You want to always infect those plants. You want to hit them with fertilizer and then harvest them so that you can farm up weird substance. And then elsewhere on the farm, you can do a fertilizer and then a weird substance that you know you're never infecting your healthy plants because you're automatically curing the infection from the fertilizer. It's a very weird system. I feel like the farm would really need to be larger than this. I don't know how large the farm gets. Oh, there's 9 upgrades. Okay, the farm can get very big. So yeah, by the time you get into rank 9 or even like rank 6, you've definitely got a large enough farm that you have space to create sacrificial squares to create the farm weird substance along with your fertilizer. So that makes sense. But yeah, so there's a lot of depth to this, it looks like. So we've only tapped like half of the growable things here. So we've got the grass, we've got hay, we've got bushes, we've got carrots. We're now getting into, we got trees, we just got into pumpkins. So at some point, we'll probably end this episode here, but we'll have to get into sunflowers. Mazes give us treasures, interesting. Cactuses, and what is this here? Dinosaurs in the next episode. But really interesting programming puzzle game. So there's our pumpkin farmer achievement. I have played kind of pseudo programming puzzle games, like for example Kaizen: A Factory Story. It's not line coding, but using the kind of programming bar at the bottom to program specific machine movements, like moving an arm, grabbing an item, dropping an item, doing a cut. That is a form of programming, just not line coding. It's more like a symbolic programming. But I would classify that as a programming puzzle game. This, I'm not going to say it's unique because I've not played enough puzzle games to know whether or not another game has done something like this. I'm sure it has. I'm pretty sure Zachtronics themselves had more of a programming puzzle game. I think Shenzhen IO. It's not, I don't think it was pure line coding like this, but I think more of a programming puzzle game than Kaizen: A Factory Story was. But yeah, very interesting way to gamify programming, and I think a very clever educational tool to ease people into programming who have no experience in programming. So I am kind of excited to get into this one a little bit more deeply and see the more involved challenges that they have here that you do have to solve with a more limited version of Python that doesn't have all the kind of tricks that you can do with real Python. But yeah, really cool idea. Very almost cozy. having some music, I think, would help this a lot. But definitely like the farming vibes, the fact that we're a drone wearing a little like farmer's hat, very cozy vibes here, makes it a very chill experience for something as intimidating for some people as doing line coding is. But definitely something that I am enjoying so far. But if it's something you're enjoying so far, then hit like and subscribe. If you want to check out The Farmer Was Replaced for yourself, head on over to Steam and pick it up. And if you want to let me know what you think of the game so far, then hit the comments down below. But whatever you do, I'll see you right here again in the next one. So until then, bye-bye.